Nowadays, operating systems can handle tasks at once, but sometimes they have to deal with a problem called a deadlock. A deadlock can occur when there's at least one process which is waiting for resource to be released by another process in order to finish the task properly. Here we can see a graph in which process A is waiting for resource R2 to be released by process B to finish a task. At the same time, process B is waiting for resource R1 to be released by process A to finish a task. This is called starvation, and because process B can't begin until process A finish, which will prevent the system from moving forward. Many techniques can be implemented to stop or prevent a deadlock, and a deadlock can occur if all of the following conditions in the system are fulfilled simultaneously. This condition are called the Kaufman condition. Mutual exclusion states that each resource can be assigned to only one process at a time. Circular wait states a process is holding a resource and requires more of the resources which is being held by other processes. Recess holding is when one or more processes can hold and wait for other resources to become available for use. Last is a no preemption, which states that each resource can be assigned to only one process at a time. Another slight variation in a deadlock situation in which there are two or more processes that are in a constantly changing state. This is called a lifelock. And the major difference here is the process is not actually stopped at all, but instead just become too busy to respond to one another. Detecting a deadlock involves keeping track of both resource allocation and the requests that are currently pending from the processes. One of the techniques is called resource allocation. It is an illustration that can be done to show what process had the potential to become a deadlock, which creates an easy to follow visual for user to understand.